And here we go. Hello, everyone, and welcome to the Weekly Space Hangout for Friday, October 13th?
14th.
14th. I'm going to do that again. Hello, everyone, and welcome to the Weekly Space Hangout for Friday, October 14th, 2016. I'm Fraser, Cain, publisher of Universe Today, and joining me this week, we've got a cool group of guests who I will try to bring up now. There we go. We've got our regular Morgan Renberg. Hey, Morgan, how's it going?
Hey, Fraser, going pretty well.
You're back from the desert?
Back from the desert.
Which desert were you at?
I was in Death Valley and then in the Mojave Desert. So far too hot for October, I'll tell you that.
Was there some cool science reason you're in the desert, or was it just a vacation?
No, these are places on Earth that most closely resemble environments we see on Mars. And so since we haven't yet put people on Mars, we might as well go suffer in the desert for a bit and see what it'll be like.
But about a million times more habitable than Mars.
Yeah, no kidding.
Yeah, exactly. All right. And so Morgan and I are going to be talking about, we got a bunch of stories. We're going to be talking about 2 trillion galaxies. We're going to be talking about Obama's announcement to support the Mars exploration with humans, and the fact that ExoMars is going to be arriving next week. So it's going to be a very Martian-based episode, which is fine. You people are cool with that. And then we've also got a special guest, and our special guest is Tyler Finley from EarthCam. Tyler, how's it going?
Pretty good. How about you? How's it going, everyone?
All right, so there we go. There's Tyler. So welcome to the Weekly Space Hangout. Thanks for joining us this week. So why don't you give people sort of a brief introduction, who you are, what you do, and what is EarthCam?
Sure. So I'm Tyler Finley, and I'm a graduate student at the University of Alabama in Huntsville. So the Sally Ride EarthKAM project is a digital camera payload that's aboard the ISS. And a couple times out of the year, an astronaut will set the camera up for us in a window facing the Earth, and then students from all around the world can request photos of the Earth from space. So the Sally Ride EarthKAM project is pretty much the only Earth observation platform on the ISS that's completely controlled by students. And we've been on the ISS for about 15 years now, so we've been able to take a lot of pictures from all around the world, and it's a great, STEM education and outreach tool to kind of get students excited about space and Earth sciences.
So how long has this camera been on board ISS?
Right. So the project was founded by Sally Ride, who was our first American female astronaut in space, way back in 1995. And back then it was called KidSat, and it flew on a couple of shuttle missions. And then in 1998 it was renamed EarthCam. And it flew on a couple more shuttle missions, and then it went on the space station in increment 1 in 2001. So it's been on the space station as long as the space station's been around. After Sally Ride passed away in, I think, 2012, it was renamed in her honor to the Sally Ride EarthCam. So it's been up there for a long time, and I think it's the second longest running science payload on station.
Wow. And so what sort of in terms of capabilities of the camera, technology wise, how does it function? How do you sort of get access to the pictures and stuff? So what kind of camera is it?
Yeah, so it's a Nikon D2 XS camera. It's about 14.2 megapixels, so it's a pretty decent camera. The way it's set up is the camera's put in a window facing Earth. It's connected to a laptop, and we're able to communicate remotely to the laptop to send picture requests up to the laptop, and then the laptop talks to the camera, tells the camera when to take the pictures, and then the pictures are sent back down to us where they're going through a little bit of image manipulation, and then they are put up on the gallery for users to see.
So I'm just going to put up a couple of images that are taken. There's one here that's fairly recent of a hurricane.
Yeah, that's a great one. So this was taken from our July 2016 mission, and this is Hurricane Celia out in the eastern Pacific Ocean. This is an incredible catch for us to get this eye of a hurricane. So that gallery you're in has a bunch of annotated images. So when the images come down, there's not anything on them. It's just, whatever the camera's taking a picture of. So here we kind of add annotations to them to point out to viewers, interesting things going on in the images, and it helps students and educators use these images for STEM curricula.
I got a question here. Sorry, we're going to continue here. So you talked about what kind of camera it actually is. What kind of, like the streaming? How much data can you pull off the station? How many, how long can you do this for?
Right. So we operate about a week at a time, and I should mention during a mission week we operate on a 50 millimeter lens for about the first half of the week, which is about 180 kilometer by 115 kilometer footprint that you're going to get a picture of on the Earth, and that equates to roughly 30 meter resolution, which is about as good as Landsat data. It is visible though, so it's not quite the same. And then in the second half of the week we switch to a 180 millimeter lens, which gives you about an 8 meter pixel size. So these are very clear images, and you can see a lot in them when you zoom in. I don't know exactly how much data we can get through, but I can tell you the past mission we took almost 4,500 images during the week. So whenever there's daylight, we can take a picture. And usually people request pictures over land. So whenever we're over land, we're probably taking pictures the entire time.
But this is all automated, right? Like you're sort of defining the characteristics in advance. You're not having an astronaut go to the window and take a picture.
Right, exactly, which is wonderful. We don't have to have an astronaut sitting there, pressing the button every time. So we kind of conglomerate all of the picture requests through the website and put them into a camera control file. And then the camera control file is sent up through some software we have through Johnson Space Center up to the station. And then from there, it's all automated. The camera takes pictures based on when the laptop tells it to. So there's a program running on the laptop that kind of commands the camera, and then
right.
When there's ample bandwidth and there's not as much other science going on, they send us the pictures back down.
Now I've got a couple of questions that have come in from the audience right now. So the first one comes from Chris Clark. How do you avoid lens flare and reflections when you shoot through a portal? So is there any kind of lens flare reflections, especially when the sun's up?
Right. There is sometimes when you get to sunsets, there's not a whole lot we can do about it. We kind of fixed some of the contrast in our image manipulation at the end. We run it through some image property management, and you can kind of get some of the lens flare out of it, but we kind of set apart the areas where you can take pictures where you should get clear images, too long before sunset, and you're going to start getting those flares.
Right. And then another question comes from David Curry. The pictures seem to have more dead pixels than before. Is the camera system getting damaged?
Right, so something that NASA is very interested in, and so is Nikon and other companies involved. Cameras, I forget what part exactly of the camera, but the pixels can be damaged by a lot of the radiation up there on the station. So as time progresses, you will see more and more dead pixels in your images. With that said, that camera has been up there for a few years now, and we're hoping to replace it here in the next year with a new D5 camera. But that's right, the pixels will kind of age and some will go dark, because of the radiation up there.
And I've got one last question, which is Larry Beckham wants to know if you've ever pointed the camera up at the night sky. Have you taken any pictures of stars?
No, we haven't ever done that as far as I know. The camera's always positioned in a nadir window down towards the Earth. So I don't know if we'd be able to take pictures of stars if it were pointed up. Currently, we can only take pictures during the daytime, so there would be a lot of smear from lights at night. It's not that precise to get those city lights.
Now Now, before we were setting up, you were saying that you're sort of in a bit of a fishbowl. So where are you actually sort of located right now and like processing the images? You said like people can kind of come by and see what you're up to?
Right. So the Sally Ride EarthKAM project is operated in conjunction with UAH as well as the Space and Rocket Center here in Huntsville. So during mission weeks, we operate out of our Mission Operations Center at the Space and Rocket Center, which is an active museum, and there's space camp here. So we're set up kind of in the middle of the park, and I'm watching guests walk by, enjoy the rides and check out the rockets out here right now. So people can, peer through the glass and see what we're doing during mission weeks. Sometimes they find their way in and ask us what's going on, which, we don't mind. We love talking about EarthCam. But it is nice in that we can interact a lot with the guests and talk to them about EarthCam and get them excited. With SpaceCam here, there's a lot of students and a lot of kids running around. And to get them in here and to be able to request a photo from space just makes their day. So, it is a blessing and a curse. We're here where everybody can see us, but at the same time, we get so much more exposure because of it.
What's that process then? So if I was, if I saw that you were at work and I came over and, my son wanted to see a picture from space and requested, I guess it's not instantaneous, right? But at the same time, the ISS, it's above some location. So how would that work?
Right. So you say instantaneous. Previously, the EarthCam mission operated out of UCSD, San Diego, and it recently, within the past year or so, moved over to the Space and Rocket Center. We've been able to kind of finagle our way to get images taken and then back down and posted on the site within 24 hours, which is pretty incredible. So that people used to have to wait a week or more sometimes to get their images back. But the way the site works is you can request an account, to sign up to participate in EarthCam. And we kind of originally, EarthCam stands for, knowledge acquired by middle school students, but we accept all forms of informal and formal classrooms, elementary all the way through college, and even homeschool and even Boy Scout troops, things of that nature. So as long as you're affiliated with some kind of educational thing, you can request an account and, take pictures. So for the people that are here, if they just get lucky and happen to come by while we're taking pictures, we're happy to let them use kind of a guest account that we've created and request a picture, and then we kind of email them the results back.
That's what I was going to ask about. It's just like what's involved to actually do that. So, are you like the Hubble Space Telescope? Are you totally overbooked with viewing locations, or how is it?
Right. So we actually, whenever the camera is over land or the station is passing over land is when we get the most requests. It always works out where, like I said, this mission we took about 4,500 images, but we had maybe 12,000 requests. So the software is smart enough to notice, hey, there's a couple requests within a certain time period, say 5 or 6 seconds. So it conglomerates all of those requests into a single image request. But each of the schools that requested those individual, images is credited for taking that picture. So there is a lot of, requests for it, and it's very busy, but it doesn't affect your request. So if it goes over Los Angeles and you want a picture of Los Angeles, but so do 20 other schools, you will all get the same picture.
A couple of people have been asking, are there any restrictions on places that the camera's allowed to view? Some places you're not allowed to? Area 51?
Yeah, that's a good question. Actually, we don't have any restrictions on what you can take pictures of. So if it goes over it, you can request a photo. The data that we get back, the pictures aren't precise enough to make out anything like that. Speaking of Area 51, we saw a news article from an Indian school where they had quoted a student as saying, "I was able to take a picture of Area 51," which we thought was pretty funny. But no, as far as I know, we've never had any restrictions on taking pictures over certain areas.
Are there areas that you just can't take pictures of because the orbit of the ISS doesn't pass over that? If I wanted a picture of the North Pole, could I get that?
Right, that's a great question. So the orbital inclination of the space station is about 55 degrees. So anything north or south of 55 degrees in latitude, you will not be able to take a picture of, which is kind of unfortunate, but that's just the only way we can operate because the station isn't in that kind of polar orbit.
Right. Cool. Well, I think we're starting to run out of time. So, Tyler, can you let people know sort of where they can find out more information and be able to actually participate?
Yeah, definitely. So just go to our website. It's earthcam.org, EarthCam with a K. You can also follow us on Twitter at EarthCam Live. And there's a lot of information there on how to fill out an account and how to request images. So definitely check it out if you're a science teacher or anyone looking, just interested in being able to take pictures of the Earth from space. Definitely check it out.
Fantastic. Tyler, thanks for joining us on the Weekly Space Hangout.
Yes. Hey, thanks so much for having me.
See you later.
See ya.
All right, Morgan. There he is.
I'm here.
Then there was just us. And all this nonsense at the bottom. I gotta clean up this bottom of the screen. Oh well. And now I turn off that, and I turn that on, and now we've got Morgan's lower third. You have no idea what I did because you can't actually see the output of the show, but that's fine. It looks just awesome. All right, well, let's move on. So we're going to talk about a bunch of stories that you queued up this week, and we've actually got a lot of time because it's just you and I. So I think we'll have a chance to just go deep on these conversations. So first, why don't we talk about, turns out there are more stars in the Milky Way than I've been saying in all my videos. I keep saying there are 100 to 400 billion stars in the Milky Way.
Well, actually, this doesn't change the number of stars in the Milky Way. What this is changing is the number of galaxies that we think are in the observable universe.
Right, and I say 100 to, 100 billion to 200 billion galaxies in the observable universe.
Right, and that's absolutely the number that we've been working with now for 10 or 15 years. And that was a number that was derived from observations made by the Hubble Space Telescope. So what Hubble did is they took its camera and it pointed it at a patch of sky that seemed to be basically completely empty. We didn't see any stars or galaxies or nebulae or anything like that. And it took a very, very long exposure image of this blank area of the sky. And the result was a very famous image called the Hubble Deep Field. And it showed many, many galaxies in an area that we thought was basically completely blank. And then a few years later, I think this was in 2004, they went back with a different area and did it again, took an even longer observation, and that became known as the Hubble Ultra Deep Field. And now Hubble's observing a tiny little fraction of the night sky at any given time when it makes one of these observations. And so we were basically able to count up the number of galaxies that we saw in that image and multiply that by sort of the fraction of the area of the sky that Hubble was able to see in one picture. And when you multiplied those two things together, you got a number that was somewhere around 100 to 200 billion as the number of galaxies out there in the universe. And we should be careful here to say this is the observable universe.
Observable universe, right.
Part of the universe that we can actually see.
Yeah.
But that light in 13.8 billion years has had enough time to reach our telescopes and our eyes. We have no idea how big or how many galaxies exist in the universe at large, but the observable universe is large enough that it gives us plenty of things to be fascinated by. Yeah. And so what this new research did is not actually take new observations. They took these old observations and reanalyzed them. And what they did is they took these pictures and they broke them out into 3D. So it turns out that the farther away a galaxy is from us, the redder it looks. So if we took our galaxy and somehow jumped out of it and pushed it billions of light years away, it would look redder and redder and redder the farther away from us it got. And so the redder a galaxy looks, the farther away it is. You can take this image and break it out basically into a 3D map. And what they discovered was that earlier on in the universe, galaxies were much denser together. And that's not a big surprise because the universe was much smaller billions of years ago. And so all that stuff had to be crammed down into a smaller area. But they also noticed that there were many more galaxies and that they were all much, much smaller. And what this tells us is that early galaxies, which were relatively small, must have been combining together over and over again over the course of billions of years to lead us to the galaxies we have today. But if you take one of these faraway regions of space, and remember that far away means long, long ago in the past, and you add up all of the galaxies that are in there, they don't add up to be enough mass to make up the galaxies that we see today. And it tells us that you need about 10 times more stuff early on to combine together to form the massive galaxies that we see today. And what that's telling us is that even though we can't see them, there must be something like 10 times more galaxies in the early universe than we previously anticipated.
But this doesn't necessarily, change those calculations then, right? It's not like we say, okay, so there's, we now know that today there are 100 to 400 billion stars in the Milky Way, and there, now maybe in the early universe there were 2 trillion galaxies. Therefore, doing the math, maybe there's 10 times as many stars. It doesn't mean that, right?
Right. So nothing's changed from the perspective of what we can see. So it's still safe to say that we can look out in the night sky, and our technology allows us to see a couple 100 billion galaxies. But what we can now know is that there are 10 times as many galaxies that are just too far away and too faint for us to see. And that all of those early galaxies were a lot smaller, which means that they're adding up, they're combining together to make larger galaxies that have the same number of stars they always did, but the individual building blocks that went into merging these galaxies together were smaller billions of years ago than they are today.
Right, and that's one of the big questions, right, that the James Webb Space Telescope is going to try and help answer is what did that early universe look like as those early stars were forming, as those early galaxies were coming together and forming those building blocks that create the galaxies that we see today. So it's sort of good timing that they've got a sense that the early universe is not what they necessarily thought it was, and we'll be able to do a lot more research on this next level. So right. As they're saying in the chat, bring on the JWST.
Yeah, if these calculations are correct, it's telling us that James Webb should be able to see many more galaxies in any given region of the sky than Hubble did. Hubble's mirror is about 2.5 meters across. James Webb's mirror will be about 6.5 meters across. And the amount of light that you can collect with the telescope goes up as the square of that number. So that's something like 5 for Hubble versus like 40 for James Webb. And so James Webb's going to be able to collect substantially more light than Hubble, see many of these fainter objects, and confirm that these calculations hold up.
Fantastic. All right, well, let's move on to the next scene here that we've got, which is that we're going to be talking about Obama is jumping on board reaffirming NASA's plans for Mars. So, and it's sort of funny timing, right? So just as we get the big Elon Musk announcement, they're going to be sending hundreds of colonists to Mars. Within the next 8 years or so, we get another announcement coming out of the White House.
Yeah, in some ways, the biggest news here is that there isn't any new news. So this week, President Obama published on CNN an editorial that sort of looked back on his life and how the Apollo space exploration played a role in inspiring him as a child. And he breaks down a few of the things that went into making that possible before coming around to the idea that our generation will be doing the same thing on Mars, and that he hopes one day that he'll be able to introduce his grandchildren to exploration on Mars in the same way that his grandparents introduced him to the landings on the moon. But from a substantive standpoint, he didn't say anything that was different than the plan that he had sort of laid out 6 years ago, or the slightly more fleshed out plan that he directed NASA to develop in the last couple of years. And in fact, in some instances, the language he uses is almost exactly the same, advocating for putting humans in orbit about Mars in the mid-2030s, returning them safely to the Earth, and then only afterwards attempting to place humans on the surface of Mars. And did you get any sense then that he was reacting to Elon Musk's announcement in the last couple of weeks? So he certainly played up the idea that NASA is working together with commercial partners to make this sort of thing happen. And that had actually always been in his plan. It was congressional leaders who were sort of pushing back on large-scale involvement from the private sector and wanted to keep NASA itself focused on developing these core technologies. So I think, and I certainly don't know the president, but I think he would be quite pleased if a private industry was capable of achieving these sorts of things. Uh, and I think that he sort of tipped his hand in the sense that he's not providing NASA with the resources necessary to accomplish landings on Mars, regardless of what he says. The NASA budget has been flat over the course of the Obama administration. There hasn't been substantial forward progress in human spaceflight. And there's not even really been sort of a continuous rhetorical effort to drum up national interest for human spaceflight. And so I don't doubt that the president has personal interest in this, but it clearly hasn't been a priority for him in the first 7.5 years of his administration. And the reality is that come January, either President Clinton or President Trump will be free to shape their own policy for NASA. And that could look very different than that of President Obama.
Yeah, I mean, this is something that we've talked about in the past, that it's very difficult for any president with a 4-year term or even with an 8-year term to be able to create any long-term meaningful plan unless they, literally the first thing they did in getting office is just commit the country to this goal and get the Congress's approval and get the Senate's approval, and everyone's aligned and NASA's ready to go, and they then you could get something like the moon missions, over the course of, from when Kennedy stated the initial address to when humans were actually walking on the moon was in less than a decade, right? So,
right, I think you can't overlook the fact that it was a decade to decide to go to the moon on it. And that spanned 3 presidential administrations. But by the time it began to cross from President Johnson to President Nixon, the inertia was already unstoppable, and this was going to happen. When you're talking about going to Mars on a timeline of even Elon Musk isn't really seriously thinking about landing people on the moon or on Mars for like 15 years.
He promised 2024. If it's if the flight goes in like 2026, we won't trust anything he says from this point on.
But even that is going to get by guaranteed span presidential administrations.
Yeah.
And the overall effort is likely to span more presidents, more Congresses than any previous effort. And without NASA having some sort of autonomy separate from the ebb and flow of the political process, it's not clear how they can maintain the inertia necessary to follow through with such a large-scale endeavor.
Yeah. I mean, I think that all of the pieces that they're building right now, the SLS system, the Orion capsule, some of the other work, the asteroid capture plan, some of the roving missions that are going to Mars, some of the other exploration that they're doing. I mean, these could all be used in a larger Mars mission, but it definitely isn't. I mean, it definitely is not a firm commitment that this is going to happen. And even like a firm commitment in politics doesn't mean anything, right? I mean, it's like you've really got to have laws and bills, and to actually make something of this scale happen is a level of commitment that's far above and beyond. And at this point, like how much longer is he going to be in office for? 2 months?
Yeah, I mean, if you look at the main components of this system, which would be the Space Launch System rocket and the Orion capsule, they're not actually slated to fly together as one unit until after the next presidential election. And so it's really easy to cancel a development program that hasn't actually produced any results. And so to think that, this president is going to order the undertaking of research and development that won't even possibly be done until after the tenure of the next president tells you how tenuous a process this can be.
Man, we are so jaded. I don't know. Well, of course, we even jaded about Musk's announcement. It's so funny. I never expect that anything's going to happen, and I never expect that anything's going to happen. Even if it does happen, it's going to happen on time. Like, our very best option is that something will be cut back to the bare minimum, and it will happen a decade late.
Yeah, that's human spaceflight for you. It's
Yeah, I know.
incredibly challenging thing, and if you don't go in it with eyes wide open, then you're not going to come out of it at all.
Yeah, totally. All right, well, let's talk about the final story that we've got here on the docket. And this, speaking of Mars, we've got a mission that's going to be arriving at Mars in just a couple of days.
Right. If you want to look at the part of space exploration that is functioning much more positively, you'd look at robotic exploration. And this is working well both here in the United States, but also globally as well. And you might remember back in January, we covered the launch of the ExoMars mission. And this is a joint mission between ESA, the European Space Agency, and Roscosmos, the Russian space agency, to send a lander and an orbiter to the surface of Mars. This is actually the first part of a two-stage mission. The second part will reach Mars hopefully in 2020, including another orbiter and a rover. But the first part has now been traveling in space for the better part of 9 months. And this coming week, it will make its arrival at Mars. This is one of the sort of most dangerous, difficult aspects of any Mars mission, and where we failed the most times is trying to successfully arrive at Mars. And so we'll have not one, but two instances of that this week. Because the probe that we sent is this weekend going to separate into two separate distinct spacecraft. The first is called the Trace Gas Orbiter. And not surprisingly, this is the orbiting part of ExoMars 2016. And what the Trace Gas Orbiter is going to do is exactly in its name. It's going to look for small signatures of rare gases in the atmosphere of Mars. And after decades of studying the surface of Mars, really in the last few years, we've redoubled our efforts to understand the atmosphere of Mars. We sent the Methane spacecraft to Mars in 2013. Then we had the Indian Mars Orbiter mission. We have the Trace Gas Orbiter arriving this year in 2020. The UAE Mars Explorer will arrive to study the atmosphere. And so we're starting to put all of these pieces together. And the piece that the Trace Gas Orbiter is going to help answer is, does Mars's atmosphere have methane? Methane is a fascinating gas, because here on Earth, the vast amount of methane we have comes from life. Most of it actually comes out of the stomachs of cows. But all sorts of life can create methane. And so if we find it on Mars, that raises questions about whether or not we might have the potential for life on Mars today. And a couple of years ago, Curiosity actually made these observations. As it was driving across the surface of Mars, it recorded a series of pulses of methane gas that seemed to appear, be very strong, and then quickly dissipate over the course of a couple of months. And Curiosity wasn't really designed to study this kind of gas in great detail. And so what the Trace Gas Orbiter is going to be able to do is localize where on Mars and when on Mars any methane is detected. And it's going to be able to find it in much smaller quantities than Curiosity could, down to the level of 10 parts per trillion of methane. And even more than that, it's not just looking for methane. It's going to look for all sorts of other atmospheric gases. And depending on which ones you find in the presence of methane, will tell you whether or not we think this came from life. For example, if we find methane, which is the simplest carbon gas, in the presence of the next most simple ones, ethane and propane, that tells us that a biogenic or life-caused origin of this methane. But on the other hand, if we find it with sulfur dioxide, or a compound you often find in rocks, that tells us this is likely abiogenic or not derived from life. And of course, neither is going to be 100% slam dunk understanding, but this is really important information, because if we see it with sulfur dioxide, and we don't see any propane, we don't see any ethane, then to pretty good certainty we can rule out the idea that this is coming from life.
Yeah,
And that's an important thing to do.
Yeah, I mean, this is one of the most compelling, most interesting trails that astrobiologists have been going after for the evidence that there could very well be life on Mars. Is this discovery that there's methane in the atmosphere? You know, that it's these chemicals that can only be that break up so quickly within a couple of hundred years that they can only be visible because there is some source that's producing them. And as you said, you know, either if it's biological, then it's methane, ethane, things like that. If it's, you know, sulfuric, then maybe it's volcanism. Although both are super interesting, you know, because the question of active volcanism on Mars is still sort of an open question as well. So either way this breaks, it's still a very fascinating question, and it's like all of the spacecraft up to this point haven't had the capability to really answer this question. They've provided these tantalizing glimpses, and then you sort of counter that to the mission that was done with the like the Viking back in the 1970s, where they took a little bit of soil and they heated it up and they added some nutrients and they got some chemicals out of it that were evidence that there was some kind of life form, bacteria, whatever, consuming it, but still the results have been really unclear, and that just pushed the whole process of exploration on the surface of Mars back. And so now NASA's coming back around at it, going very, very carefully. Was there water in the past? Is there water there now? And now they're still continuing down that route, but now we have this whole other path, which is this search for the methane in the atmosphere. So it's a pretty, you know, it's amazing to think, like, if they do find it within a couple of months, maybe within a couple of years for sure, we will know if there is biological life on Mars or keep looking.
We'll have at least a good idea.
Yeah.
And as exciting as all this is, that's only half of the ExoMars mission.
Yeah, so why don't we move on to the other half then? So what's the other half going to do?
Yeah, so they're also going to be dropping a lander into the Martian atmosphere named Schiaparelli. And Schiaparelli is named after Giovanni Schiaparelli, the first astronomer of Italian origin to draw an essentially complete map of Mars. This is back in the late 1800s. And we actually derive many of the names of stuff on Mars today from his original map. And this is very much technology demonstration. Neither ESA nor Roscosmos has ever actually successfully landed something on the surface of Mars. And so rather than put all your eggs in one big expensive basket, they're testing out this simple lander to show that they sort of have mastered these techniques. So this is a lander that's battery powered, no solar panels, no radioisotopic heat source. So it's only going to last somewhere between 2 and 8 days. And they're dropping it actually in a location on Mars that we've already explored. This is Meridiani Planum. And that might be familiar with some of you because that is where the Opportunity rover landed back in 2003. But just like ExoMars is carrying different instruments or just like the trace gas orbiter is carrying different instruments than previous orbiters, Schiaparelli is carrying different instruments than previous landers. In particular, it's designed to measure the relationship between the electric field at Mars and the dust environment. It's being dropped in an area on Mars where large dust storms are very common, at a time in the year where dust storms are most likely to happen. And scientists have puzzled for a long time what causes these enormous, sometimes global dust storms to take over Mars. And we think that one factor that contributes very strongly to this is the presence of an electric field that can lift up dust off the surface, kind of like magic. The dust gets a little bit of an electric charge, and we know that electric fields repel electric charges, and it floats that dust up where the wind and other climate effects can start to take over and whip it up into a storm. And so for the first time, Schiaparelli is going to be able to make measurements of how much dust is in its vicinity versus how much electric field it can experience on the surface, and try to develop a correlation between those two things. And it'll make these measurements as well as it drifts down through the atmosphere of Mars. So it'll be able to tell us at different levels in the Martian atmosphere how much dust is there. This is something that MAVEN has been doing at high elevations for the last couple of years. It dips down to just a couple hundred kilometers above the Martian surface and then goes up to space. But it can't get down lower than that, where atmospheric drag would basically cause it to crash into the surface. Schiaparelli is crashing into the surface, and so it'll be able to pick up where MAVEN left off and make these measurements step by step all the way down to the surface and develop a full profile of how Mars's atmosphere is able to hold dust.
So how, like exactly when are we actually going to be able to see this happen? I know we just put an article up on Universe Today that the landing is in 5 days, and that was, I guess, today. So we're...
Yeah, so it's the 19th that both the orbital insertion of the orbiter and the landing of the lander will take place. But 3 days prior to that, so on a Sunday, is when the first major event, the two spacecraft separate. And so they've been traveling they were launched as one sort of cohesive pair. They've been traveling through space as one pair so that the trace gas orbiter can use solar panels to keep the batteries of Schiaparelli topped up. But now they will separate and basically go on their own ways as they approach Mars, take their own trajectories. And then on the 19th, at 2 different times, they will enter the Mars atmosphere, one to land, the other simply to slow down enough to enter orbit.
That's
what time of the day that is will highly depend on where you are watching this right now.
Well, I guess we're probably not going to do live coverage of it like we did for the Curiosity landing. I don't know if that was before your time, but
it was.
Yeah. Okay. Well, I think it's going to be it's going to be a pretty exciting thing. So, as a planetary scientist yourself, are there any questions that you're, really looking forward to having answered for you?
Well, I'm really looking forward to just getting a more complete picture of the Mars climate. Climate is obviously a really important question here on Earth today. And the more we've looked out in the solar system in the last 15 years, we've realized how complex the climates on other planets were. We realized that Titan has liquid on its surface. It has rain and storms and lightning and wind and all of that. And we've noticed that this sort of thing happen on Mars as well. We see that during the day, Mars's atmosphere absorbs water, and you get clouds and stuff. And then at night, that snows out onto the surface. You can see frosting taking place on the surface of Mars. And this isn't just interesting from sort of an abstract climate perspective. We think that the changing climate here on the Earth was really important. And by changing, I mean how it goes from day to night, it changes, not the long-term changes. But on a sort of short day-night cycles of having the weather change, we think that's really important to the development of life here on Earth. Because life works based on having differences. If everything was the same on Earth, then it would be very much more challenging for life to exist. But because it's warmer in the day and colder at night, you set up these gradients of temperature that can create gradients in chemicals that can then create the basic energy building blocks that simple life needs to form. And so if there's any hope of life existing on Mars today, we need to know that the Martian climate's dynamic. And all the signs we have point to, yes, it is. But, we've been studying the Earth's climate for centuries. We've been studying Mars's climate for at best a couple of decades. And there's just a lot more to learn there.
Yeah. Well, it's good. I think this is going to catch a lot of people by surprise that this mission is going to happen. We were really aware that the Rosetta mission was going to be going into that important phase when it sort of meets the comet, goes into orbit around the comet, but I don't think a lot of people out there were really kind of prepared for it, and then it became quite a news blitz. So hopefully the same thing will happen. Because once again, right, if the methane gas is discovered in the atmosphere of Mars, and it is got all of the signatures to life, it's like one of the most important discoveries in the history of science.
Certainly would be really exciting.
Yeah. This could just come out of nowhere, and everyone's like, "Oh, by the way, we are absolutely, very certain that there is life on Mars."
Yeah. If we fall back for a moment into our jaded selves,
yes,
if
we're here somewhere.
If life in the bacterial form exists on Mars, it's likely buried, beneath the surface, perhaps even deep beneath the surface. And so we might detect a signal that we think quite likely could come from life, but still be decades or centuries away from actually finding that life itself. And if Elon Musk starts sending hundreds to millions of people to Mars, we could easily swamp out that signal forever, even if we don't destroy that life.
Right. How many astronaut farts would it take to completely cover up the signal from the local bacteria?
Yeah, not very many, because otherwise we would have detected these methane signals with many of the other instruments we had. We know that the levels must be very low, and that's why we're sending such a sensitive instrument.
Yeah. Got a question here from Ignatiy Romanov-Cherengovsky. Why are they not letting it last any longer? Why are they giving it such a short amount of time to survive? And why no solar panels, things like that?
So they wanted, I think, basically to keep the design as simple as possible. And they were also, I think, pretty cost constrained. Originally, both of these were supposed to be more complex spacecraft than they ended up being, but they had to slice off a lot of instruments to meet their cost requirements. At one point, Russia was considering giving, the Russian Space Agency was considering giving plutonium to the mission to create a long-lasting power source and let them sort of set this up as a weather station. But that got bogged down in the sort of laws and regulations surrounding the international disbursement of nuclear material. And they weren't able to sort of sort that out in time to meet their budget or their timeline.
One less
very simple thing.
One less Russian plutonium missile, that would have been good.
Yeah. It would have been a great thing for this lander, but it ultimately, as a technology demonstrator, they wanted to invest their money in the orbiter, which is designed to last for years. It's ultimately going to be a communication satellite around Mars, coordinating future missions, and that's the long-term asset here at Mars. This demonstration is going to show that their heat shield works, their parachutes work, their thrusters work, and put them on track for a rover to land there in just 4 short years.
Right. Okay, well, this time next week we'll give an update on whether or not whether it landed successfully and safely. So we'll know shortly.
Fingers crossed.
So we've got a little more time left, and I'm going to mention something else here that Susie, our producer, wants us to bring up, which is that at part of CosmoQuest, which of course is the nonprofit organization that I'm a member of, that allows citizens to do science, to study the surface of Mars and the Moon and Mercury and search for craters and lots of good work that you can do over at CosmoQuest. And we're trying to get a better understanding of sort of how we can help you with your with science fair projects, with what else we can do. And we got a survey for just surveys for parents, surveys for people who want to get involved in science, and surveys for teachers. And so we would really love to get your help if you sort of fall into one of those categories. If you're a parent, if you're a person who wants to get more involved in citizen science, or if you're a person who wants to get more involved in as a teacher in educating your students. So we've got, I'll give you an example here of what this looks like. So here's the sort of one of the surveys that we're doing. Now, if you go to cosmoquest.org, you'll be able to find all of the surveys that we're running right now, and we've got 3 of them up right now. I'm sure Susie will put a link to this in the post somewhere. And we would love to get your information. Just tell us more about how we can help you do better science, teach science, participate in science, and help teach your children better science. So that would be awesome. All right, so Morgan, where do we find out more?
Well, you can follow me on Twitter at Morgan Renberg. Next week, I'll be at the yearly Division for Planetary Sciences conference this year in sunny Pasadena, California.
Nice.
So you can expect a torrent of tweets about the absolute latest in planetary science and exploration. So if you want to be on the cutting edge of all the stuff that's happening across the meeting, I, and I'm sure many other people, will be peppering the internet with our thoughts and excitement about the latest in astronomy research.
Fantastic. Maybe we can hit you up next week and get you to give us a bit of an update. What's happening?
I think Sandy and I are already scheming.
You're already planning. Okay, great. That's gonna be so. Sandy's gonna be there as well. That's fantastic.
She'll be there as well, indeed.
Wonderful. Okay, great. And of course, I'm Fraser Cain. You can, if you haven't already, subscribe to this channel, and you should check out, we've got 2 cool new videos we just published this week, as well as a Q&A show. So if you have questions for me that you want me to answer in video form, just go ahead and post any question you like in any of the videos that you're watching. I will catch them and I will incorporate them into the newly added question shows. So thanks everyone for watching. Thanks to the WSH crew for acting as our producers this week. We really appreciate it, as always, for setting up the guest. And for just kind of providing the chat. If you want to join the WSH crew, just go to wsh-crew.net, and this is the community that is part of this. So thanks again. Thanks to Morgan. Thanks to the guests. Thanks to everyone watching, and we'll see you all next week. I'm going to